So yesterday we have started what is the inheritance. We have seen the basic concept of the inheritance, and today we'll see in detail and we'll see an example. What is inheritance? Anyone from our group? Anyone? What is inheritance? What do you guys understood from inheritance from yesterday's class? Okay, fine. So inheritance is a mechanism, as I said, it's a mechanism where one object will acquire or will access other objects, properties, and methods. It's idea. It's a where one object or one object of child object, I can say, where the child object can access a parent object's properties and behaviors. Like if you take in normal in a real time, we'll be acquiring or we'll be access. We'll have rights to access our parents' properties, and we have access to access our parents' behaviors, right? So, in the same way, in Java we have inheritance. I mean, in OOPS concepts we have inheritance, where it will explain where you can go ahead and access other objects' properties and behavior when you have a relation between these two. What is the use of it? The main use of it, where we can achieve the code reusability. We don't need to write the same code multiple times. Once you have written in a parent class or some one class, we call it a super class, and you want to make use of that. You have a situation where to there's some other place where you want to have same kind of code or same kind of method names or same kind of properties. What we will do, instead of creating it, we'll extend that class. Instead of creating a new object or instead of creating a new properties and new methods, what we will do, we will access the parents properties and methods, and we can have our own properties and methods along with them. That's called code reusability. That's called inheritance. This relation, when you have a parent child relation, it's called easy relation. Easy relation. Okay, let's take an example and we will see that. I have a class animal. It has some methods and it can have properties like name. It has a method and it has a method each. A simple, so a simple example. Okay, now I want the behavior is same. If you take any animal, if you take a bird, if you take any animals, wild animals or normal animals, if you take a cattle, any animal will have the same kind of behaviors and the same kind of properties, right? And let's assume I'm creating an object for class dog and extends animal class. And what I will do, I will have my own name. If I want to use a make use of the parent one, I'll see how to use a parent property. We can write our own or we can make use of parent one. So let's see an example in the code itself instead of writing here. or else we can write our own code. If you're not able to understand from the existing one, we can take our own class where we will define the package. Inheritance. You can give a call. You can give a class name as inheritance demo. We have okay. Class. I have animal class. Class. Okay. Let me finish this class. String name required sleep. Okay. Name of animal and return name. Let's assume that this name equal to animal. Okay. Now I have a subclasses where I have a class bird extends animal. So I can have my own name, bird name. Where I can go ahead and override these methods. We will see in detail what is a override. Okay. Now support you return the name of the bird. We'll just say bird. Okay. And I have written a class dog which extends animal the same. Here this is dog. Okay. Now try to create an objects. You can create animal, you can create a bird, create a dog, It's a simple example. We'll see one more example with the detailed. Okay. Now, when I say animal dot get name, it will give me the animal name, name, it is returning some value, right? So when it is returning some value, we need to print that. So that is the reason I have taken that. And animal dot eat, animal dot sleep. Okay. And let's take the same way for bird as well. Same take for the dog as well. Okay. Now just execute this program. Right click, run as Java application. The first part is we have created a object for animal, and it is telling that the name of the animal is the. I mean, we didn't take the specific names. We just taken the generic name. So name equal to animal, and it's animal is eating, animal is sleeping. When we take object for the subclasses, it's taken like a bird is the bird is eating and bird is sleeping, and the same for the dog as well, right? So here this is the direct, it's a tightly coupled, we'll call this as tightly coupled. It means that the animal is tightly coupled with animal only. This animal object is tightly coupled with animal. So in the I cannot say animal equal to bird. I cannot create like this. Animal equal to new word I can do. Correct. So child and parent child relation. But can I say bird equal to dog? Because bird is different and dog is different. And the bird is tightly coupled with the bird class. The dog is tightly coupled with the dog class. But how can I'm able to do animal equal to dog? I mean, or animal equal to new bird or animal equal to new dog. I can do this. Animal equal to new dog I can do. Because here a parent can hold, the parent can hold child classes object. The parent can hold child classes object. A child cannot hold a parent class object. I cannot say try to understand this. This is called polymorphism, dynamic polymorphism. We'll see that. Okay. uh, Child cannot hold a parent class object, but parent can hold a child class object. Child class cannot, or child object cannot access or cannot refer. It is a referring, ideally it is referring. The child object cannot refer the parent class object, but parent class object can refer child class object. Please try to remember this. This is the thumb rule. Clear about the inheritance? Let's assume that. Let's
Ravi,
assume. Yeah, Rama.
these are here at assigning the child objects.
Hmm.
Can you make that as a animal one and animal two, and can you compile and show the output, please?
Could you please repeat one more time?
So
Animal
here
equal.
actually,
Hmm.
yeah, here can you make as a animal one, animal two? So whatever like the child objects you created, you assign to the parent one, right? So here the bird and dog objects.
One second, I'll do
Line
that.
number 79. Line number 79, Ravi.
File number 79. Yeah.
And yeah, can you make as a animal one and animal two?
I can do that, but it has to be declared
That
before.
is enough.
It has to be declared. It
Oh,
has
okay.
to be declared. So it has to declare, right? So
Okay, yeah, that's what. Yeah, that's what. Yeah,
type should be there. What type of animal it is?
that's right. Yeah,
Hmm.
this is one. Yes.
Yeah, I can do that. So if I
So
go ahead
here,
and
like,
hmm,
yeah, go ahead.
yeah, here that's what I'm trying to say. Your parent are referred. Your parent can refer child's object. Say it's vice versa. It's not possible. Okay, it's like
Yeah.
your parent. I mean, let me put in the real word. Your parent can talk about you without respect, like he's my son, or he can he can refer you, but he cannot refer our parent without respect. He's my father. Like we can refer respectively. I mean, I can say very. We cannot singularly. We cannot refer them. We can refer with the plural only, right? But our parent can refer us with a singular. I mean, I'm trying to compare with the real scenario. The same way here, the parent can refer a child object, but the vice versa cannot be possible. And Rama, you go ahead. You have some doubt and you are trying to ask me.
Ravi, can you call these eat and sleep functions using animal one object, please?
Yes.
That's what I wanted to see the output
Yep.
actually.
So can
And
you
in
check?
this case, yeah, go ahead. Ravi.
Yeah. Can you guess which method will get called?
I think it's a both parent and child.
No.
That's what actually I wanted to see the.
Okay. Okay.
Okay.
Just go ahead and run it. What is get called,
Okay.
Rama? See,
Okay. That means okay.
here it is just a reference. It is a type of variable. See, how we will declare our primitive data types like this, right? What is I?
Hmm.
I is a variable name and int is a type, right? The same way
Yes.
here,
Okay.
animal is a variable and means ideally it's referring a object, so we'll call it a reference variable. We cannot call it as a local variable or it will not call it as a primitive variable. It is a variable name and is a type of variable. And here, what we are trying to do, we have created animal type of variables, but it is referring board object.
Child. Okay.
Yes, it is
I got
referring dog object or child object, right?
it. Okay.
When you say new, it will create a memory allocation for that class only. When I
Okay.
say new, it will create for the board, and when you say new dog, it will say it will create for the dog. What will happen here? The memory allocation will happen for the dog, and memory allocation will happen for the board. Inside that, the variables, what are the variables we have in the dog, or what is there in the bird, so those will get called. Even though we are referring with a parent reference, but we are referring to the child, so child properties and behaviors will get called.
Okay.
Clear, Rama? Yeah. Ramya,
Yeah.
you're asking me to explain one second, right? Let me take a different example. You may it may clear you. I'm taking here inheritance demo 2. I'll just take only two fields, because it will be very simple. Employee, and the employee has salary. Let's assume that He has some salary, some dollars. Let's assume that some dollars. Okay. Now I have one more class where I can say developer or programmer. Extends employee. Okay. And where he can do his own variable. He has his own variable. Let's assume that bonus. He has, let's assume that some $5,000 or $500. Okay. Now I'll create a object for only child. I'll not create object for the parent. Program will just take anyone name, random name taking Ravi. Okay. Now the Ravi has an access because he has a parent child relation with a right. Ravi can access Ravi dot salary. He can access the parent one, and he also can access Ravi dot bonus. When I go ahead and execute this program, I hope you are able to see. Is able to access both. Is it clear, Ramya? Ramya, is this clear? Yeah. So this is a single level inheritance. We have only single level inheritance. If I have something extends programmer and has some examples. I mean he has his own properties like and when you go ahead and create an object for your developer, I have taken a small name, I'm going to take a long. So naming convention, even if you take small names, it doesn't say error or something. You can take the smaller. It's just a convention. As we explained yesterday, just a convention. Now I can go ahead and access. Sorry. So it is a multi-level. Forget about the first two. First two is printing from here, and the Vira salary and Vira his bonus and his incentive. Like this, not only like this. If you has any program, any methods here, any behaviors, you can go ahead and access them. You can go ahead and access them. Let's assume that public display. He's just displaying. How can I access my parents method? You can go ahead and access. It's very simple. Vira dot display. Because Vira doesn't have that, but still his parent has it. You can access. You can go ahead and access. The same way, Ravi don't have any method, but his parent has the method, so you can go ahead and access them. Clear, right? And the same time, let's assume he has his own method. Let's assume your developer has his own method. Try to understand, guys. This is very much important. Print, and he's printing something here, saying that I am a developer. I code and I create. Let's assume that something he's telling here. He's a developer. And what he thought, okay, before that, I want to call my parent. Before that, I want to call my parent method. In my method, I want my parents' behavior with me. Along with my behavior, I want my parent behavior here. You can go ahead and call super dot your display. Super dot display. Super is represent your parents object. Super is represent always your parent object. We will see super and this detailedly coming classes. Okay, just remember super will represent all your parent and this will represent your current class or current object. We'll talk about this and super later point of time. First time we just try to understand here. So now I'm going to execute this because I didn't call my
Yes.
method. I didn't call my
Yeah,
method.
we
So
did.
yeah,
Yeah, yeah, we need to solve it.
Vira dot print. So when I call print method here, let me call the display also here in between here. Go ahead and run it. Clear, guys? This line is printed from my print method. Let's assume that. Let me comment this. I don't want to call that. Then go ahead and run. Now you'll get a clear idea. Now see my salary, bonus, and incentives. And when I call my print method, this is what I'm doing in my print. But along with this, I'm calling my parents also. I'm an employee, belong to some XYZ company. I'm a developer. I can code and I can create. Clear, guys, about inheritance?
Here I have one more question.
Go ahead, Rama.
So let's consider the child and parent has the same method. Method name is same.
It can be same name,
So
it can be different name. Yeah, go ahead.
yeah, same. I want to go with the same name condition.
Okay,
So let's consider like here, the parent has a display, right?
okay. I'll go ahead and create one more method here. Display
Yes,
the
in
same
child.
method, same method. Yeah, child
Yes, same. Yeah, yeah. But only in the print system out, you just give. I am a like based upon it, I am a programmer.
developer, employee and developer.
Okay. Yeah, the same one.
Hmm.
Now, what you do is whatever the object you created with the developer, can you call with this display function
Hmm.
with the developer object, please?
Sure. Can you guess? Try to guess what will be the uh, uh, what will be the output, Rama? At least
So
can you
I'm
try to
guessing the
guess?
output should be both. Output should be from parent and child, but I want to know which calls first.
No, Rama. It will come from child only.
Oh, it comes from child only.
Yeah, because the object is belongs to child. But even though you have the same method, same behaviors, you have overridden already.
Okay.
It has been overridden.
Okay, okay. So this where the override concept will come. Okay.
Yes, yes, it's called override. Actually, when we do these kind of things, we'll use an annotation called at the rate override. We'll see detail about override and overload and override. You have overridden your parent behavior. Let me take a small example. Our father, our parents has a his own of walking style and laughing style. He has his own of he's has his own walk style, and he has a the laughing also. He laughs differently. He has his own property. When we inherited, I mean, so when we inherited from the child, when he came from the parent, sometimes we'll get the same kind of behavior from parents, right? Let's assume that I got my parent behavior, which is a walking style, and I also got the parent behavior, which is a laugh, how he laugh. Then later I realized that okay, it looks like a old style, so let me make it little bit modification. Then I modified that style, the walking style and the laughing style I had just modified. Then what happened, when anyone, if anyone looks me, they will not say my parent, they'll say me it's my own, right? Because I have modified it. I have overridden my parents. If I didn't override, if I didn't override this, if I didn't override this, what if anyone looks at me when I was laughing and when I was walking, they will say, "Oh, he's following his parent style." I mean, he inherited from his parent style. He has inherited from his parent style, right? So understand, right? So I'm trying to correlate with that kind of real time. So when you override, your own with the same behavior, the name of the behavior with the same name, so it will get overridden, and you will not get your parents. If you want to get your parent explicitly, we can go ahead and call them here super dot. We can say that. Understood, Rama? Any doubt? Hello?
I'm good, Ravi.
Yeah, okay.
So that means like here, Ravi, if you wanted to have our own, that means if we have same name between uh, parent and child,
Okay.
if you call it a child object, it is for only its own method, right?
Yes, it will prefer the one first. It will check whether in this object we have any method or not. If it is not there, it will go ahead and call parents.
Okay.
Let's assume that I don't have this method here. We have seen already this. Then what will do?
Hmm.
Still I'm able to access the display. It will call the parents display.
Okay.
Clear, Amma?
Yeah. Thanks.
Yeah, we'll see in detail about the overload or override concepts. It has some limitations and it has some rules to follow. We'll see them later point of time. Okay. So this is about inheritance. Okay. Next, jump to abstraction. Next, next concept is abstraction. What is abstraction? What is abstraction? Anyone? Anyone has any idea what is abstraction? What is abstract? Okay. In college days, we will be submitting our major project or minor projects, right? Before submitting the project, in the timeline, before this date, what we will submit, we'll submit abstraction. I'm going to do this. An idea, a model, right? This is the problem statement I'm going to solve. This is the abstraction. But is that abstraction has the actual implementation? No, it is just an idea. Here also, here also, we have a concept called abstraction in Java and oops, in a whoops concepts. The abstraction represents hide unnecessary details to the client end user. So client in the sense end user show only the functionality. Show only the functionality. Let's take a simple example. We have a car. We know how to drive a car. We know how to take reverse or go forward, escalate, and I mean we know how to use of it. But do we know how does functional internally? I mean, until unless we're mechanic students or some who was very much interested, they'll go ahead and know it. But all the drivers know about it. Correct, Chandu. So process of hiding the implementation details and show only functionality. Correct. So when you take an abstraction, when you take a car, so we know how to drive it. I mean, who know how to use of it. We don't know how it's functional internal, how it functional internal, how the fuel is getting converted into power, how the wheels are start rotating forward or backward, right? How the odometer is working, how when you give the escalator, how when how it is getting escalated and how it is moving fast. We don't know that. We don't know the functionality, but we know how use of it. That is called an abstraction. So hide unimplemented details from the end user, just show the functionality. Clear? Any doubt on abstraction? How we will achieve abstraction in Java? By using abstract keyword, we will use abstraction. We will achieve abstraction. By using abstract keyword, we will achieve a abstraction. So we can use abstract for two, I mean two levels I can say, method level and class level. Abstract class, abstract method. There is no abstract variables. We have only abstract method and abstract class. And what is abstract class? What is the abstract class? A class which declares in front of the class, a class, the class as declared as abstract in front of the class will treat as abstract. And what is the difference between the normal class and abstract class? We'll go ahead and see now. The abstract class, just say the syntax of the abstract class is we have to use abstract and a class and the name of the class. And we can go ahead and write our own functionality. But it is just an idea. It is just an idea. That's what abstraction, right? That the abstraction is just an idea. We're not going to really implement anything on it. It is just an idea. So someone has to implement it. When we submitted abstract into our department in the colleges, like in the your BTech or MCA or your MTech, when we submitted the abstract to them, we have to provide the implementation for it. The same way here, for this abstract class, we have to provide an implementation. Someone has to provide implementation. Until unless someone provides implementation, this is no use of it. No use of abstract class. Someone in entire the life of the project or some place in the project, they have to make use of abstract class. Or someone has to create a child for this abstract class. If no one is created a child for this abstract class, there is no use of this abstract class. So when you create an abstract, someone has to implement. Let's take a car example. I have designed a new car, just a design, and I have modified some engine capacity, something we have modified, but someone go ahead and implement it, right? If no one is implemented it, it's a waste. Just an idea, nothing else. So no one is using it. Let's assume that there is one guy he created a car model, and no one is implementing it like your Chrysler or Subaru or BMW or Audi. those guys are not using that abstract. Those guys are not using, when any car manufacturing company not using that model, so there is no use of it. Clear, guys? That idea, if someone is making use of it, like Maruti, or if you take any company, Toyota or Subaru or Chrysler or Ford, anyone, any of the manufacturing company, they have to make use of that idea, that model. Then there is a use of that abstraction. Otherwise there is no use of that abstract. Am I clear, guys?
Ravi,
Yeah, Rama.
yeah, Ravi, I have a question.
Mm-hmm.
So in between, you use like to implement this,
Mm-hmm.
you said how to create the child.
Yes.
Can't we create an object to implement this abstract class?
No, we cannot create object for the abstract classes. I'm coming to that point
Okay,
actually.
that is a fundamental, that is a rule of thumb for the
Yes,
abstract
yes,
class.
yes.
Okay,
If we create an object, we can start
one
accessing,
implementation.
right? Yeah.
Yes. Okay. So
Understand,
that
Ram?
means in order to implement a functionality of the abstract class, it should be done only through
Child
child
level.
classes.
Yes, yes.
Okay.
And even if you see our Java APIs, there are the top level abstract classes. If you take most of the APIs, even if you go with our MapReduce, in the MapReduce also we have abstract classes in top level. All these abstract classes always will be in the top level. So the implementation will come in the low level. Like if you have a mapper class, you have a mapper class, abstract class is there, interface is there. If you have a reducer class, I'm just giving an idea. We not yet come to that point. It has abstract class. It has a downline, the child classes which we are going to create, our own mapper class, our own reducer class. These are abstract classes.
Mhm.
Always the abstract classes will be in top level. It has to be. If it is not in the top level, there is no use of it.
Okay. Ravi, maybe I just trying to recollect something. So, like maybe I'm trying to compare the Java with C++. In the C++, so a class will be called as abstract if it is a pure virtual function. The
Okay.
same valid here.
Yeah, the pure virtual function means that function will not have a body implementation, right, Rama? I
Okay.
forgot the concept, right?
Okay, because by default, yes, normally, we will create a pure virtual function without body, but that will be called somewhere in the child. The
Correct.
same concept will also.
Yes, here the same concept. We're going to see a small example that will make very much clear. Okay. Yeah, let me try to and explain existing code instead of writing. It's writing the code is eating up our most of the time. Do you have any? Yeah, I have abstract implementation here. Abstract demo I have. We will create abstract class by using abstract keyboard. And actually, it is not abstract demo. It's abstract class. It's I have named it very wrongly. It's just abstract class. Abstract class should contain at least one abstract method. And what is the difference between the abstract method and non-abstract method? We'll see that. Abstract method will not have a body. Non-abstract method or concrete method will have a body. Okay. And these are non-abstract methods. These are non-abstract method. And these are abstract method. These are abstract methods. Your abstract method will not contain any body. Sorry, this is not abstract method because this is a main method. Your abstract method will not have a body. Your non-abstract method will have a body. Okay. You can ask me, Ravi, can I have a constructor and abstract method? Abstract class, sorry. Can I have a constructor and abstract class? Yes, it's always welcome. You can have a constructor in your abstract class. Then you can ask me, Ravi, you said that I'm not going to create an object for the abstract class. Then what is the use of it? We will see that. Okay. Abstract class, we cannot create object. We cannot say like new, let's say, let me take complete name, abstract demo ad or ad abstract demo equal to new. I cannot say like this. I cannot say like this. If I say like this, it will throw an error. If I say like this, it will throw an error. Let's see. Anyway, we have a main method here. Yes, already there. What it's telling? Cannot instantiate the type of abstract demo. Cannot instantiate. Why? Because in front of the class I have used abstract keyword. If it is abstract keyword, I cannot instantiate. I cannot create object. Then, if I cannot create an object, what is the use of this constructor? I cannot. If I am not able to create object for this class, what is the use of this constructor? Constructors are meant for the allocating the memory. Constructors are meant for the create an object. Constructors are meant for the assigning the values after creating an object, right? But if I'm not able to create an object, what is the use of it? We'll see that. Clear, guys? For abstract classes, we cannot create objects. Are you guys clear about what is abstract class? Abstract class, if you use abstract keyword in front of the abstract class, the class become an abstract class, and that class can contain concrete or non-abstract and abstract methods. The class can contain concrete method along with the abstract methods. Then what is abstract method? Abstract method will not have a body. It's just a declaration. There won't be any definition. If your method don't have a definition, you just declare and close with a semicolon like this, and by using the abstract in front of it, it is called abstract method. If try to see, can I create without abstract? I'm trying to do. What it is telling? This method requires a body instead of semicolon because I didn't declare abstract in front of here. If you declare in front of the method as abstract, the method cannot have a body. Let's try to keep a body. What is telling? Abstract method do not specify a body. You cannot have a body for the abstract methods. And if you want to make a method as abstract, it should not have a body, and the method should declare with the abstract keyword. Clear, guys? And this is abstract method, and others are non-abstract methods. Non-abstract methods can called as concrete methods. Concrete methods can have a body, and it can have a written value. We can do some operation in that. But when it comes to abstract methods, we cannot have any body. Clear, guys? Let's see this example, and this is abstract class. How to make use of this abstract class? Are you guys clear about this demo? I mean, this abstract class. This abstract class. If you want to make any class abstract class, you have to create with you have to define or declare an abstract keyword, and you can have a variables, and you can have a constants. You can have any type of variables, and you can have a constructor as well. This is one of the interview question. Can a abstract class can abstract class can have a constructor? They'll ask, may I have a constructor in abstract class? Yes, you can have. Abstract class can have a constructor. And there is one more question. Can I have a private method in abstract class? Yes, I can have a private method abstract also. That's what the abstract class can have a normal method as well. That's called concrete methods as well. Our display and display 2 are concrete methods. It can have our our abstract class can have concrete methods as well as abstract methods, and also it can have a private methods, and also it can have a constructor, and it can also have a variables. I mean variable where you can declare. Is it clear, Amya? Okay. So then you can ask me, see Ravi, you said that abstract class is just an idea. Okay. If you have a private method in that, what is the use of it? Someone has to access, or someone has to implement it. If you keep a private method, it is a private to the abstract. It cannot be accessed in the child. If it is a private, we cannot access in the child. I forgot to mention in the inheritance concept. If anything in inheritance, if anything is a private, if anything is private, the child cannot access it. I mean, actually, I have a separate session for the access modifiers, so that is the reason I skipped here. If something is private, the child cannot access here. If something is private, the child cannot access it. It's a private to parent. It's a only available. The scope of that variable is only within the that class only. We cannot access outside the class. Okay, Ravi, if we say that if abstract class has a private methods, and what is the use of it, then that also I'll show you. Okay, we may not able to access that private method outside the class, but I can access inside the class. I can have that private method inside the class. If you see my display 2 is a private, I can call from within other method. I can call from through public method within the class, not outside the class. Right? Okay. Clear guys? I'm going to show the implementation of it. Are you guys clear about the abstract class? These are the interview questions you will face from the this concept. They may ask you, can I have a constructor in the abstract class? Yes, you can have a constructor in the abstract class. Then what is the use of it? I'm going to show you the use of it. Then can I have a private method in abstract class? Yes, we can have a private method. What is the use of it? I can call that private method from a non-private method or a concrete method. Clear guys? And can I have a main method in the abstract class? Yes, I can have a main method in the abstract class. What is the use of it? Just go ahead and try to run this program. Sorry, what happened? It has some errors in the project, don't worry, not in the class. I'm able to print. If I want to execute only main method from the from my abstract class, I cannot access any other things. I cannot access my these behaviors. I cannot access my constructor. I cannot access my display method or display to method. I cannot access these guys, but I can access only with whatever you write in my main method. I can access them. Whatever I do in my main method, I can access, but I cannot access other part. Right? If you have a requirement where you want to execute only abstract class with the main method, we can go with like this. We can execute or we can enter into the abstract class by using main method. Use of it, there is no much use. We never write a main method in the abstract classes. In the real time, we never write this kind of main method in the abstract classes, because here we may come across the interview questions asking that can I have a main method in the abstract class? Yes, you can have a main method in the abstract class. To clarify that, so I just keep the main method in the abstract class. Clear guys? We can have a main method in the abstract class, we can have a constructor in the abstract class, we can have a private method in the abstract class. You guys clear about these three? This is very much important. You guys surely will come across at least one or two questions from here. Okay, now let's go ahead and see the implementation part of it. What it is telling, add an implemented method, because I have added a new abstract method. Okay, in implementation part, when you are going to implement that abstract class, you have to provide an implementation for all the abstract methods. Let's say I have a car design. So when I want to fulfill the design by my BMW or Subaru or Maruti or something, what I have to do? I have to provide a complete implementation for all the methods, right? All the behavior of the car. Then only I can achieve the 100% design implemented. I can say I have my design has been implemented 100%. So whatever the abstract methods are there in the abstract demo, you have to provide the implementation. Else it will say it has to it'll say that not implemented, so you go ahead and implement it. It'll just say you can go ahead and implement. Clear? Then you ask me what is the use of the constructor in abstract class. Now see, in implementation, through implementation method I can call, see how to implement. We have to extend the abstract classes, like we have to create a child for a abstract class. Now my implementation, my child class can have a constructor, right? My child class can have a constructor. From my child class I can call my parent class constructor. From child class constructor, from child class constructor I can call my parent class constructor. How can I call? This is the way how to call. Super. Because why I'm passing two parameters, my parent class constructor has two parameters, so I'm calling with the two parameters. If my parent class doesn't have any parameters, I no need to pass any parameters from here. I should not pass any parameters from here. If I pass it, it will throw an error. If my parent constructor has three parameters, or my parent constructor has multiple parameters, the parameter list should match here. The parameter list should match here. Parameter is nothing but what are the variable we declare here. That is called, we'll call as a parameter. Okay. This is the use of constructor in the abstract class. Okay.
Ravi, if I keep super only one parameter, by default second parameter, won't it be considered as zero?
No, it will not consider as zero. See, Ram, if you
Okay,
see what it will happen, it will try to look for this. It will try to look for the same signature in the parent.
okay.
It is not like something it will take a default. No, I'm not even. If I specify comma and if I specify some value, then it's good. If I didn't specify, I'm just passing one parameter only. It is like this is capable of taking one parameter only. See, if you take our methods, right? We have a method which has a two parameters, and you are calling that method with one parameter. It will not get called. It will not identify that signature, right?
Mm-hmm,
Signature should match, right?
mm-hmm, mm-hmm.
So the same way, when you're calling your constructor, parent class constructor, I'll say in within the same class constructor, the parameter list should match, because it'll start search for the same signature here also. Clear, Rama? I think still you have a doubt.
I'm good, Ravi. Like Ravi, can you go back to the parent one?
Yeah.
Maybe here, in the here, like if I give into j equal to 100.
Here, I cannot assign the value directly here.
Okay. Sorry, because there is other concept in the C++. I'm trying to relook correlate with that.
Okay.
Okay, Ravi, go ahead with it, Ravi, because maybe with the comparison I am trying some confusion.
Okay. Okay. So clear, right? About this?
Yeah.
Okay. So this is the use of the constructor having having in abstract class. So I may call from, I have some my own requirement. I may call from my subclass. So that is the reason the your abstract class allows to have a constructor. Okay. Then as I said, whatever the abstract methods are there in our class, these are all abstract methods. These three are abstract methods. We should provide implementation for it. We should provide implementation for it. Let's see here. I have provided all the implementation here. We should provide the implementation. If we didn't provide the implementation, it will throw an error. Compile time error. And we'll see what is a compile time error, what is a runtime error. We'll see them in detailing. Okay. Just print three is just you can implement your own way, whatever you wish. I'll be sharing these programs, guys. I'll be uploading into the drive. Just excuse me, because right after the class, the it is taking some time to record, and after that I'm getting ready to rush to office, so I'm not uploading that time. But whenever I get a free time, I'm just started uploading this. I'll try to upload right after the class now on. Okay, these all examples I'll be uploading into the. I have created a separate folder in the drive called Java code, so there I can upload these classes. You can download them. You just can have a reference. It's a very pretty simple examples. This is nothing complex examples, and you guys can once you understand, you can write your own. Okay, so now I have to provide implementation for all my unimplemented methods. What are the unimplemented methods? The unimplemented methods are nothing but abstract methods. Abstract methods, right? And these are non-abstract methods. So non-abstract methods, you no need to provide any implementation, but you can call them. You no need to provide any implementation, but you can call from your child. We know that. So we can call our parents method. Let's see what I'm trying to do here. I'm creating an object for the I'm creating an object for the child class, and with this child class I'm calling the display method. What is the display method here? The display method is this. I am from the abstract class, and I am from the abstract class constructor. I mean, sorry, this is to private, right? And I'm just calculating because I have implemented some method called calculate method. What is the calculate method? Just a plus b or I plus I plus j, and I'm printing that out, and I'm doing a sum of. There is a one more method called sum. All the purpose of both the purpose is same, but I just for explanation I have taken this, and I can call print method also. Okay. Now clear about this? I'm going to show one more. Okay, let me execute this. What did happen? I called a display. Before that, I called a constructor, right? As soon as you create object for the child class, as soon as you create this child class here in the line number 23, it will get called the constructor, right? It will get called the constructor of the current class. To which class we are creating object, that class constructor will get called. See here, abstract impl class I'm creating object for it. The abstract impl class abstract method constructor will get called. If you don't have a constructor, your compiler will keep a default constructor. If you don't write this constructor here, your compiler will keep constructor, but your superclass constructor cannot call. Okay, then there it is called my super by passing 1000 and 2000, and that is the way here it is get called. I am from the abstract class constructor, and the next line is I am from the child abstract impl. Then I call the display method. I am from the abstract class. The display method is printing in. I'm the display method printing here. I am from the abstract class, right? And private is because in your abstract class you are calling a private display. So this private is get printed, and I have calculated. Sorry, not this. Let me go back to this. Then I have calculated. I have called this calculate method, which I have passed 10 and 30. So it's get written 40. I have printed that 40 value here, and I have entered under 100 and 200 for this sum method, and I call this here. Clear? Okay. If you guys are clear, I'm going to show one more way of accessing it. As I said, a parent can hold a child class object, right? I can go ahead and do here. I can go ahead and do here. It is allowed. It can do. We can create a reference to abstract class, but we cannot create an object to a reference object to a constructor class, abstract class. We can create a reference to abstract class. We cannot create object to a object to abstract class. Clear, guys? Clear about this? And what is the use of AD? Whatever you access through AD, it will get access from child only, not from the parent. We have seen in the previous example, right? The object will be created for this and it is just referred by your parent, nothing else. This object is type of abstract demo, but it is referring, it's the value of this is child, right? The simple, let me put in the simple way. You have a bigger vessel and you have a small vessel. Okay, the small vessel can go into the bigger vessel, but vice versa is not possible, right? Let's assume that there is a bigger vessel, and from there we got the small vessel. You might have seen the stack of boxes, and what they will do, there will be a bigger vessel, the slightly small vessel will be there in that, they will keep in that, there will be again the small vessel will keep in that, or box or whatever you call. The same way here, the abstract is the top level, it means it's a bigger one, and abstract implementation, the child is the small vessel. So the small vessel go into the bigger vessel, but the bigger vessel cannot go into the small. So the same concept here. So you kept the small vessel into the bigger. When you start pouring something, water or something, it will go into small vessel and it will not go into the bigger vessel. But from outside we are seeing it as a bigger vessel. You guys got my point, what I'm trying to explain here? Let's assume that there is a bigger vessel and you have a small vessel, slightly small, it is like, it's not very small, it's a slightly small, let's assume that. And this bigger vessel can, I can keep this in this, and whatever I pour into this vessel, it will go here only, it will not go here because it's a slightly small, it's not like, right? So the same way here, your parent is abstract class can hold or can keep your subclass object, but whatever you're trying to access through that reference object, it will be referring child only, it's not, it will never refer the parent. Clear guys about the abstraction? I hope now you guys are clear how to call a parent class constructor. This is the way to call parent class constructor. This is the way to call parent class constructor. We cannot call a subclass constructor, but we can call within, we can call, let's assume I have one more constructor here, but it should be same, cannot be possible. It should have at least a parameter. Let's assume that I have one more constructor. This is called constructor overloading. If you guys remember the method overloading, you guys can easily recollect what it is trying to say. Implicit super constructor abstract demo is undefined, must specify invoke another constructor. Here, this, sorry, this of, I'll be calling 10, 20. When I say this, as I said, this is represent the current class. So this will get called this one. And when I say this of 100, it will call this. But ideally it cannot call like that. Each other cannot call, right? They should not call each other also. I can do like this at least. If they call each other, it's never end, right? This guy will call this and this guy will call this. So that is the reason it's shown error before. So if you want to call a constructor in the same class, we have to use this. And one important thing is here, when you want to call a constructor, either super or this within the call class, the super or this statement, the very first statement in the constructor. There should be very first statement in the constructor. Let's assume that I cannot have like this. I cannot have like this because this or super should be very first statement. Either I can use a this or I can use a super. Okay, both I cannot have. If I have a, and also this cannot be, I cannot keep in here because the this and super should be a first line of the statement in a constructor. If you are using the this, or if you are using the super, either of this should be a very first statement in the constructor. If it is not the first statement in the constructor, if you keep on after some lines or after next line, it will throw an error. It will say that it has to be, it will throw a compiled error. It will says that this super has to be a first line of the statement in the constructor. Clear, guys? Any doubts? So this is about abstraction. This is about abstraction and inheritance. Tomorrow we'll see polymorphism and encapsulation. So once we done with encapsulation polymorphism, we'll see inheritance, and we'll see sorry, not inheritance, interface. We'll see interface, then we'll jump into the collections. Okay, and I have uploaded one document which contains the programs. Uh, Please, you guys, please practice those programs, and I'll be uploading this today. Whatever we have discussed, I'll be uploading these files as well. So please try to practice this. Clear, guys? Yeah,
Yeah,
and in yeah, Rama, go ahead.
yeah, I have a question for this Hadoop.
Okay.
So, what extent of Java we need? So this is enough, whatever you are the
Yeah,
OOPS construct, or do we need advanced also?
advanced in the sense, Rama, we don't need JDBC, serverless, JSPs, and all.
Mm-hmm.
For at least for the map reduce. For if you are going with the complete architecture, like let's assume that I have a data is there in a HDFS. I want to access the
Mm-hmm.
data through a application, through a Java application, some
Mm-hmm.
other application. So then I need a web
Mm-hmm.
services. Web services is again, it's a different concept altogether, right?
Okay. Okay.
So for this processing the data for map reduce and all, core Java is enough. Core Java, in core Java, we should know whoops. I mean, whoops will cover most of the inheritance or encapsulation and abstraction, polymers and all. And
Okay.
whoops, and we should have. I mean, anyway, the flows like if else conditions, switch conditions, those are I'm not going to drive because those are pretty similar in all the case to all the languages. Switch or if else conditions, for loops, okay, uh, and some this kind of control flows I'm not going to drive them. If it's undif, I mean logical and logical are uh, operators, I'm not going, because if we start teaching all these things, if we start explaining all these things, the time will take more. It may go 20 days or 30 days, I mean 20 hours or 25 hours. So that is the reason I'm just skipping them here. For the map reduce we need oops, and we need to know what is interface,
Okay.
collections, and we need exceptions. Threads are
Okay.
not required, but uh, I'll just give an introduction for the threads. Threads are not required for the that purpose. And here strings and string buffer. These are small concepts. String builder, buffer. Yeah, these concepts are enough. Oops, interface, collections, exceptions, string buffer, and in collections only we'll get the map, set, array list, linked list, vector. There are so many things will comes under collection.
Okay.
These things are important, Ram. If you if you see any of the, I'll just show you here a small example for map reduce. What are the concepts we are using there? At least you'll get an idea. If you see a join example I have tried here, maps are join. If you see a mapper class, I'll be using extend here. It means inheritance. Okay, and I'll be using hash map, which is a collection, and this is the list. It's also collection, and this is the for loops and strings. I'm using the string, and this is again a map, again as I shown you above. And this map method is belongs to our mapper class Hadoop related wala. And this is, if you see here, IO exception, interrupt exception, these are belongs to exception. Clear, Rama?
Yes, Ravi.
Yeah, so these are the minimum the core topics are important. I mean, it doesn't mean that we should not know other things like if else conditions, for loops, switch, and logical and logical are, those are programming basics, right? We should know them, because I'll be using for loop here. I'll be using if else conditions. Those are important. Those we should know at least. String builder, string buffer. Those things we should know at least. Okay. Yeah. So, anyone has any other doubts? Okay. If anyone has the doubts, please stay back. Others can leave for the day.